we have to switch to our next presentation. Again from UNR, Dr. Hamid Ebrahimian on the investigating the potential application of elastomeric polymers such as polyuria for accelerated bridge construction and retrofit.
Yes, hi. So good morning in the West Coast, and I think good afternoon in the East Coast. Can you see my presentation?
Thank you. Yes, we can see the presentation, colorful picture, and your is coming very well.
All right, this is our campus, which is of course right now closed. So, so probably you will see similar thing right now. No people around. So anyways, the project, thank you for the opportunity. The project that we propose to work on is on the, as you mentioned, the application of elastomeric polymers, mainly polyuria and polyurethane for accelerated bridge construction. This is a project that in collaboration with Dr. Mustafa, and we haven't yet started, of course, on the project, but we have identified the student, and we hope to start the project within this summer. So in this presentation, I would like to kind of give you a brief outlook of what we are going to do and what is the subject and of this project and what we intend to pursue. So let me get started by telling you a little bit about what is polyuria. It might be a new kind of terminology for some people. So polyuria is an elastomeric polymer. It's derived by the reaction of some petrochemical materials with some synthetic resin. Traditionally, it has been used for waterproofing and kind of concrete coating, as you see in the figures. So it's a commercially available material, but it has some mechanical properties that makes it very interesting and useful, including a high tensile strength and a tendency for self-healing and rebounding. So as I said, commercially it has been used for waterproofing and weather resistance, but it also has some interesting impact resistance properties, and I'm going to show you this video. Hopefully you will see it well. So the polyuria will apply it as a spray coating, as you see in this video, and when you apply it, then it has an incredible impact resistance due to some local transition to in a material level, local glass transition. As you can see, there are two blocks. One is painted with polyuria and the other is a regular block, and you can see how the basically significant effect that this polyuria can have in enhancing the strength, especially for impact type of loading. Of course, because of this interesting property, it has been used for military applications, for bulletproofing and blast resistance, and there are some companies that are actually applying this material on a commercial basis for these applications. Now, on civil structure side and civil engineering side, there is a good amount of literature devoted on studying the performance of this material for blast resistance, as I mentioned. Now, for example, this is some videos that I take out from, these are some figures that I take out, snapshots I take out from this video here, which was the result of the testing that is done here. And they were focused on studying the effect of polyuria and blast resistance on masonry walls. So basically there are two similar masonry walls, and one of them, the polyuria wall, has been back coated by polyuria, basically spray painting. As you can see, this is the back of the wall. And then there has been a blast test, and the outcome is incredible, that basically the control wall will fail, but the polyuria wall will stay in the place. And the reason is that this material can locally become nonlinear, transit into a glass material with a very high tensile strength and viscosity effect that can absorb a lot of loading and dissipate a lot of energy locally, and it will result in basically the structure stay intact. And I have heard that the material has been used for reinforcing U.S. embassies in Middle East in order to make them blast resistant and kind of blast proof. So there are some good military application, but of course not a lot of materials on these properties, and testing and specifications are available on the military applications. So on the structural application, also, if we look at the literature, there are some limited works on application of this material for civil structures. Mainly, a very good work has been done by Professor Myers at Missouri S&T, and they have applied basically polyurea to different type of structures, including beams and slabs, in order to understand the effect of this material in reinforcing and enhancing the flexural and shear resistance on the beam and the slabs. And also the material has been applied on storm drain pipes. And here we will have two advantages of using the material. One is the weather resistance and kind of waterproofing and corrosion proofing, and of course the other one is to enhance the strength of the structural components. So the collective conclusions that that can be obtained by reviewing the literature is that, well, first of all, the material is available, it's commercially available. It's relatively easy to apply. As you can see in all the figures, it needs some special mask and protections to apply it, but when it dries, it's a safe material. The material has a good environmental resistance to weathering, de-icing, and freeze-thaw conditions. Most importantly, the material has a good impact resistance, a very high impact resistance. Also, the literature has shown that the material can enhance the flexural and shear strength of regular concrete specimens. Most of the studies that has been done in the literature are under monotonic loading. So, and we expect, because of the property of the material, that it will have probably a much better performance under cyclic loading or fatigue type of loading, or loadings that produce fatigue. So these are on the areas that has not been explored very well. And of course, on the masonry walls and concrete slab, it has shown to have some effects. So based on this kind of motivation and understandings, we, with Dr. Mustafa, we came up with some research questions that whether can we use this material for ABC and bridge construction industry, to what extent can we use them, and how we can proceed with this idea. And so when it comes to application to ABC, there are several places that probably we can use this material. One is on enhancing the concrete barriers and pipes, of course, the first one. Second one is on joints, on weatherproofing the ABC joints, which is another probably useful application and interesting application. But we were more interested into enhancing the mechanical properties of components and systems, whether as a design solution or as a design kind of addition, and as a retrofit solutions. And in this part, there are three kind of categories that we can take into account. Of course, our interest was on girders for the first place. Applying this type of material can enhance the weatherproofing of the girders. Literature has shown, the studies that has shown in the literature, although on a limited scope, has shown that they can enhance the flexural and shear strength of the girders remarkably. And of course, when we talk about the bridges, there is another kind of hazard that that can be somehow detrimental, of course, to operation of the bridges, and that's vehicle kind of impact. So we can think about this solution as a design/retrofit solution that can have several applications. Of course, this is an idea, we need to explore it more, but in this project, we decided, considering the limited scope and also the limited experience that we have this material, we decided to focus on the flexural and shear strength enhancement due to application of this coating. So there are some limitations and gap in knowledge that, of course, we try to walk through them and investigate them. So these projects serve as really a first step towards a longer-term vision to bring this material as a practical construction material to the ABC and bridge industry. The limitations that we face is that, of course, there are limited conclusive studies on the mechanics space and mechanical properties of the material and how they can enhance the strength of the beam in flexure and shear, and also probably due to the impact. There is very limited guidance or practically no guidance on the application and also design process. On the modeling part, also we have very limited knowledge currently. There have been a lot of some good studies has been done for military applications and mainly impact resistance with the highest strain rates to characterize the kind of constitutive material models for this type of material. But on the civil engineering side and the level of the strain that we are working, there is, I believe there is, I can say no good studies, at least based on my current knowledge. Environmental and hazard effect and also cost benefit analysis. We want to see whether this material is an economic option for retrofit and also enhancing the design of bridge components. So that's cost benefit analysis, also a big question that we want to answer. So based on these ideas and knowledge gaps, we came up with a small project including 4 different tasks to kind of examine the application of these materials for ABC construction. Of course, task 1 is literature survey. We want to understand what has been done on this material very carefully. The second one is coupon testing. So we preferably, in order to develop some material models for civil engineering application, we want to have some simple coupon testing to drive the material models, at least the behavior of the material, to inform further modeling steps. Task 3 includes numerical implementation and fine-tuning study, in which we use what we learned from coupon testing on the material behavior, and then in this step in the task 3, we're gonna combine it with some models of concrete specimen, mainly beam and girders, in order to understand how this material can help the flexure and shear strength, how they can help the failure mechanism, and what is the extent of that advantage that the material can provide. We are anticipating, if our time and project budget allows, we are anticipating to even test some smaller scale beam specimens in order to kind of verify our numerical studies. And once we have a confidence in the model that we have, then we can do some parametric studies, and most important, some economical cost benefit analysis to see if this material really can be introduced as a useful technology or material to the bridge construction industry. So this was a very short presentation just to present the scope of our work and what we are headed for, and I would be happy to answer any questions that you may have.
Yes, thank you very much, Dr. Ebrahimian. Yes, we have quite a few questions. One is that just like every polyurethane material or so, I guess this question comes from that. What is the long-term performance of this material?
Right, so there have been some research has been done on studying the durability of this material. And I think I kind of mentioned it very briefly. So the material has been shown to have some good durability exposed to de-icing, freeze and thaw, and also the sunlights, basically. But again, there is no conclusive research on this part, and it's also a good question to be answered.
Great. And I think I didn't hear in your presentation, this is my question, what is the setting time of this polymer?
the setting time. So as you can see, it's actually very fast. As I showed you in the video that, let me go to this video that I show you, is actually it works like a paint spray. So as they apply it, it will dry fast. I don't have any, again, because we didn't have any experience with this material. We didn't have any hands-on experience. I don't have a good answer, a good quantitative number to tell you, but I imagine it's fast.
Okay.
But within a few minutes, probably.
Okay. The next question is asking, how would you assess the, I guess, the benefits, the cost benefits or benefits, if you, without doing testing?
Without doing what? I'm sorry.
Testing, like beam testing or any type of testing.
So the first question that we want to answer is that how much this material will cost. For example, if you want to use it for a retrofit solution or for addition to design solution, how much this material would cost and what is the gain that we get out of applying this material, for example, to a concrete beam. So if the material costs a lot and the gain is not a lot, for example, we can gain 10%, 20% increase in the strength, but we have to spend a lot of the cost of the material, the cost of application is high, then we can do some judgments that this material can find a practical way into the field or not. So kind of to come up with some numbers, how much strength we'll gain, how much benefit will we gain, and how much would it cost.